The last portion to this section is we would like to do a little bit of application. And we're going to take these ideas that we just looked at in terms of simplifying and put them into a story problem. So here we've got an airplane flying over an ocean and a kid looks out a window. He sees a banana tree on an island and calculates the angle of depression is 3 degrees. He then travels 24 miles and notices the angle of depression is now 17 degrees. How high off the ground is the plane? So we'll draw a little sketch here. We've got the plane, and we've got the banana tree down here. And the kid looks out the plane to the banana tree, and the angle of depression, here's the direction the plane is traveling, is 3 degrees. The plane then travels further. Kid looks out again, and the angle of depression is now 17 degrees. And we know the distance here traveled is 24 miles. The question then is, how high off the ground is the plane? In other words, from the top of the tree, since we're neglecting the distance from the top of the tree to the ground, is how high off the ground is the plane? So right now I've got to come up with a relationship with two triangles. And the idea here is that right here I've got a big triangle where the angle is 3 degrees. I've got a side of x and an unknown length here, unknown length here. Then I've got a second triangle here. It's a little smaller. I've got the same x side. I know the angle of depression is 17 degrees, and I've got two unknowns, looking down at the tree and the horizontal distance covered here. The piece that I do know is that this horizontal distance is now 24 miles less than what we had when we started. So we need to come up with a relationship that relates these two triangles together to some trig functions. So I ultimately need to find x. And if I'm going to be working with this triangle here, it's probably a good idea if I find this value. And let's just call this y. If I then look at big triangle here, I know that this length of the big triangle is going to be y plus 24 miles. So let's start with the small triangle. I know the relationship is that I've got the opposite side and the adjacent side to 17 degrees. So I know tangent of 17 degrees is the opposite over the adjacent, x over y. And don't get confused with x and y's in terms of the unit circle. These could be any arbitrary values. I could have chose this as h and this is L if I wanted. I then have the large triangle, which is going to be the tangent of 3 degrees is once again the opposite, which is x, over the adjacent, this time 24 plus y. So I've got a system of equations here that I've got to solve out, and I want to find the exact value from the plane to the top of the tree. So tangent of 17 degrees equals x over y. Tangent of 3 degrees equals x over 24 plus y. And it'd be really nice if I can somehow combine these together. So let's just start solving. This first guy right here, tangent of 17 degrees, if I multiply both sides by y, I get x is equal to y times the tangent of 17. Looks pretty good. If I simplify this guy down, I can make this the tangent of 3 degrees. I'm going to multiply by 24 plus y. And now both of those are equal to x. So since I've got two equations equal to x, I can now set these equations equal. So y times the tangent of 17 is equal to the tangent of 3 times 24 plus y. So now everything here is in terms of y, and I want to solve for y. So y tangent of 17, here I need to distribute my tangent of 3 into both pieces. 24 times the tangent of 3 plus y times the tangent of 3. I can move my y tangent of 3 to the left-hand side. And this is the situation that I showed you in the part where we solved the trig equations in the previous section. The fact that I got both of these variables here, I can now factor that out and I've got tangent of 17 minus tangent of 3. Divide both sides by this quantity. So now I found y. Y is equal to 24 times the tangent of 3 over the tangent of 17 minus the tangent of 3. If I pull back my original problem, though, my goal is to find the height. So what I've done right now is I found this distance right here. I need to now solve for the height. And I can do that real easily by using my original equation up here. I know that x is equal to y times the tangent of 17. And I just found here that y is this quantity. So x is equal to 24 tangent of 3 over tangent of 17 minus the tangent of 3. So we just solve that, or plug that in for y, and that's times the tangent of 17. So now we've got the exact value for x. So this right here, if we look back at our chart that we did in the previous section, that would be considered the exact value. But when I see 24 times the tangent of 3 divided by the tangent of 17 minus the tangent of 3, all that times the tangent of 17, I look at that and I say, I really don't know what that means in terms of the height above the plane. I can plug that into my calculator, and then I'll see that this quantity is actually 1.518 miles. So the plane is 1.518 miles off the ground. So here, x equals 1.518 miles.